Good morning, Professor David J. De Los Reyes. Okay, my next session will be a problem on, this will now be DC circuit or a simple problem in physics because a part of physics are actually circuitry and it involves DC circuit. This is not even a very complicated problem. Okay, let's proceed. We are given a problem here. This is DC circuit, a simple one. Find the total resistance of the given circuit. The total resistance. So the component of the circuit are all resistance. So supposed to be it is a DC circuit. The power supply is designated by a battery and it is 12 volts. I just place E equal to 12 volts for the meantime. We don't need it. The problem is only asking for the total resistance. To bring out the solution of the circuit, okay, we simplify those portions which are parallel. So I place it here. I place R1 over here and so with R2. So where is R1 and R2 in the circuit? This portion of the circuit here, they are in parallel. Right? So if we try to compute the compressed equivalent of this one, the equivalent of this one as one simple resistor, okay, this should be equal to 1 over R1. No. 1 over 1, small r1, plus 1 over small r2. I place this one as small r1, this will be small r2. So if we try to take the compressed equivalent of this, under physics, it is just simply 1 over r1 plus 1 over r2 for parallel. So if we try to simplify this one, it will be the product of r1 times r2 over r1 plus r2. That is the total resistance. That is 1 over r. That is 1 over r. So if we try to compute for this, r now will be equal to the product all over the sum, right? This is one. This is r only. This r only. The product of r1 r2 over r1 plus r2. So for r1 on this, I will just take the product of 1 times 1 over 1 plus 1 to simplify it as 1. So this will be 1 times 1 emanates from that one over 1 plus 1. So this will be 1 over 2. So the compressed equivalent of this one, since they are in parallel, to make it 1 as a single resistor, the equivalent is just simply 0.5 ohm. Okay? I will try to erase this one. So the compressed equivalent of this one is just 0.5 ohm. Right? And I place R2, these two here are also in parallel. So if I will try to take the compressed equivalent of this one, it will be same as this one. The product of 1 times 1 over 1 plus 1. And this should be equal to 0.5. So this is also 0.5. Okay? I will erase this one. I will put the compressed equivalent 0.5 ohm. So we compress this one already. We compress this one. Okay? So the total resistance now will be the compressed equivalent of this plus the compressed equivalent of this plus this. They are all in series. So I place it here, RT, meaning the total resistance, okay, will be R1, the compressed equivalent, plus R2, the compressed equivalent, plus R3. Where is R3? This will be R3. this portion here. That will be R3. You got it? So the total resistance will be the compressed equivalent of this one plus the compressed equivalent of this one plus this. After compressing it, they are all in series. So the total resistance RT will be R1 plus R2 plus R3. 0.5 plus 0.5 plus 1. The total will be 2 ohms. Good morning from Los Angeles.